More than 50 years have passed since the last lunar mission Apollo 17 in 1972. No one would have thought that traveling to the moon again will come back to NASA's plans for space exploration. But here we have it anew with Artemis missions to our satellite neighbor. Each Artemis mission has been set on a special date and time to be launched into the space to its final lunar destinations at intervals of a year or more. These missions divided and sliced up into various known and planned journeys, with Artemis I already being launched successfully and returned to the Earth in December 2022. For the purpose of this video, we will take a look at the 4 Artemis missions. Not much information has been revealed to the public by NASA about Artemis V mission and beyond because of how further away they are. Now let's find out about those 4 missions' itinerary. Artemis I was finally launched on Wednesday, 16 November 2022 after a number of cancellations and delays due to technical issues and weather conditions. Artemis I left its launch pad from NASA's Kennedy Space Center in Florida, proceeded to its interesting voyage to lunar orbit. The rocket employed in the mission is called a Space Launch System, SLS. SLS developed by NASA and manufactured by various companies such as Aerojet Rocketdyne, Northrop Grumman, Boeing and United Launch Alliance, with the height of about 98 meters and producing 8.8 million pounds of thrust on liftoff. The rocket is the most powerful ever made to date. The SLS carries Orion spacecraft, which made by joint venture of European and American aerospace companies. Orion spacecraft is a capsule and is capable of transporting crew and cargo to the moon and beyond. On the Artemis I mission, the spacecraft approached the moon and had a very close flyby of 400 kilometers above the lunar surface. Then it traveled for about 64,000 kilometers into deep space before returning back to the Earth on December 11 after 25.5 days of voyage. The module splashed down in the Pacific Ocean near California. The Orion capsule entered the Earth's atmosphere at the speed of over 32,000 kilometers per hour. Artemis I's Orion spacecraft uncrewed mission to the moon was a testbed to ensure the safety and reliability of the module for future crewed missions to the lunar orbit, the moon, and beyond. Orion is equipped with advanced technologies that no other spacecraft would come close to it. Novel technologies that require meticulous experiments in order to be green-lighted for space travel. Manufacturers of Orion spacecraft, European Space Agency, Airbus Defence and Space, and Lockheed Martin built it to endure and withstand long space journeys in order to make them tolerable, safe, and successful. Module is constructed on strict rules and regulations and have many important traits. For instance, it is equipped with the state-of-the-art launch abort system. Located on the top of Orion spacecraft, the launch abort system will be activated in milliseconds in the event of an emergency, and those accidents could be rocket malfunctioning and some other issues. The launch abort system can pull the module to safety and is also able to position the spacecraft landing safely. The system consists of 3 strong and solid propellant rocket motors, the abort motor, an attitude control motor, and jettison motor. The crew module, also called capsule, is built by Lockheed Martin in a way that can support living place for missions up to 21 days, carrying 4 astronauts without needing to dock to another spacecraft. This environment is provided by advanced technologies that make a capsule a safe and comfortable place for such voyages. One essential factor for module's ability for astronauts to travel is pressure vessel. The pressure vessel holds the capsule's pressurized atmosphere for astronauts to be able to breathe when they are in the vacuum of deep space. 7 large aluminum alloy pieces construct the pressure vessel, and they are attached together using friction stir welding. Pressure vessel is protected by a covering object called backshell. The backshell protects the spacecraft from cold of space and the extreme heat of re-entry. Being made up of 1,300 thermal protection system tiles, these silica fiber material tiles do a great job of protecting the capsule in the severe conditions in space. The bottom of the crew capsule must be protected from extreme heat of 2760 degrees Celsius experienced by Orion entering the Earth's atmosphere at the speed of more than 40,000 kilometers per hour. Heat shield is built for this matter. Its diameter is approximately 5 meters, and it is the world's largest ablative heat shield. The outer surface of heat shield is made of the material called avcoat. It is a reformulated type of material used on the Apollo capsules. When capsule is descending, the avcoat ablates burn off in a controlled manner to remove heat from Orion. On top of the crew module, there is a compartment for parachutes for capsule landing. The section is called forward bay cover. Thermal protection tiles similar to the ones used in backshell safeguards parachutes during launch, orbital flight, and re-entry. In the time of spacecraft re-entry and the altitude of about 7 kilometers, the forward bay cover is jettisoned in order to deployment of the parachute system. The crew module propulsion system is ushered for re-entry by 12 small engines, and the system is called reaction control system thrusters. The crew capsule is guided by 12 thrusters, and those thrusters ensure that the spacecraft is properly oriented with the heat shield facing downward, and also to stabilize the spacecraft during its descent. Orion's interior consists of 4 crew seats that are attached to the crisscrossing beams of an aluminum structure called the backbone assembly. Most of the crew's needed equipment to survive and live in space is stored in storage lockers, and they are also located in backbone assembly. The seats are designed in a way that astronauts in their pressure suits can reach all the spaceship's controls. Moreover, number of amenities provided for astronauts to feel more comfortable inside the capsule, such as tanks and dispenser providing drinking water and warm food. Also, the interior is equipped with 2 large storage lockers that act as a shelter for crew members in case of a radiation predicament such as solar flare, and it is located on the floor of the capsule, and it is built with dense materials. Orion will be operated by astronauts using a sophisticated display and control system equipped with an advanced software to assist the crew. Beneath the crew module, another important spaceship component is located, which is Orion's European Service Module. Provided by European Space Agency and manufactured by Airbus, the service module supplies the spacecraft with electricity, propulsion, thermal control, air, and water. To put it simply, the service module is a spacecraft's powerhouse. In order for Orion to go around the moon and return to the Earth, the service module is equipped with 33 engines of various sizes for its propulsion capabilities. The service module has 1 main engine, 24 reaction control thrusters, and 8 auxiliary engines. The main engine is capable of major maneuvering while in space in order to insert Orion into distant retrograde orbit and leaving the orbit to return to Earth. When Orion is in orbit, the 24 reaction control thrusters will be activated to steer and control the spacecraft. Transitional maneuvers are done by the 8 auxiliary engines, which are acting as a backup to the main engine. In different emergency situations, even after the launch abort system being already jettisoned, the propulsion system will come into play and can safely bring crew back home to Earth. The entire Orion spacecraft's power is supplied by the service module's electrical power system. Module has 4 solar array wings generating power for a spaceship. An electrical power system is in charge of managing and distributing this power. Light taken from the sun would be converted into electricity with the help of 15,000 solar cells that shaped 4 solar arrays. For maximum power, the arrays can turn to stay aligned with the sun. Potable water, nitrogen and oxygen stored in tanks are provided to the crew module by the consumable storage system of the service module. The water delivery system supplies potable water, which is enough to cover usable water needs of the crew for the duration of the mission. Gas delivery system provides oxygen and nitrogen. An amount of gases in each tank can be adjusted based on the mission profile. Shortly before re-entering Earth's atmosphere, Orion's crew module will be separated from the service module. At the end of the mission, the only portion of Orion that will return to Earth is the crew module. In later missions, more components will be reused, but on early flights, only high-value crew module components such as avionics, environmental control, and life support systems will be reused. Artemis I mission was analyzed and reviewed in March 2023 by NASA to investigate some issues that had happened during its voyage to lunar orbit. The problems were related to malfunctioning of power system on Orion's service module, heat shield issues on the crew capsule, and some damages that done by SLS rocket to mobile launcher. NASA, European Space Agency, and Airbus have been working on these problems, and as stated by them, the complications will certainly and undoubtedly be rectified before planned Artemis II crewed mission in November 2024. Artemis II mission is set to launch in late November 2024, will carry 4 astronauts to the moon's orbit using SLS mega rocket and Orion spacecraft. The mission's length is approximately 10 days, with purpose of collecting data on Orion and the crew's performance. The collected data will then be assessed by astronauts and mission controllers to assure the readiness of Artemis program to send people to the moon's surface. Radiation in cislunar environment is higher compared to low Earth orbit. Therefore, new spacesuits are required for crew to endure and withstand the harmful radiation existing in the environment between the Earth and the Moon. Artemis I mission had the spacesuit tested on mannequins inside the Orion spacecraft. However, testing it on humans is a completely different scenario that should be seriously taken care of. For instance, astronauts must be able to freely move their body in order to engage in agile movements in case of an emergency, and also be able to do activities within the spacecraft, such as using controls and doing exercises. Contemporary spacesuits used by astronauts are not comfortable enough and will quickly tire the space travelers. More importantly, current spacesuits cannot handle the higher radiation rate of moon voyage. Artemis II crew are 3 people from the US and 1 person from Canada. Reed Wiseman, Victor Grolover, and Christina Koch from NASA, and Jeremy Hansen from the Canadian Space Agency. During the first crewed mission, Artemis II will be a crucial test of SLS and Orion spacecraft systems. 4 major metrics of readiness should be achieved in the journey: mission planning, system performance, crew interfaces and guidance and navigation systems. In order for Orion to be able to do translunar injection, it will be going to orbit twice around the Earth, known as hybrid free return. This path should be taken to gain momentum and speed for a spacecraft to do the maneuver. Then Orion will make a direct return back to the Earth by swinging around the Moon on a free return trajectory. The mission will bring a spacecraft to expected maximum altitude of 8,889 kilometers above the Moon's surface. Artemis II, currently planned for 2025, will send 2 astronauts to lunar surface after more than 50 years of the first moon landing. 2 astronauts will land on the lunar South Pole. The first woman and first person of color are chosen for this significant mission. Orion spacecraft will be launched by a Space Launch System, or SLS, carrying 4 astronauts. The rocket and Orion spacecraft atop of it will depart from Launch Pad 39B at Kennedy Space Center in Florida. The mission will be carried out in multiple steps. In order to perform system checks and solar panel adjustments on Orion, the crew will first be launched to Earth orbit. Subsequently, Orion, with the help of a powerful push from SLS interim cryogenic propulsion stage, will perform a translunar injection maneuver to be positioned into its trajectory to the Moon. A spaceship should place itself in a lunar near rectilinear halo orbit, NRHO. In order for Orion to flawlessly positioned in the orbit, crew must travel toward the Moon for several days and perform corrective engine burns to intercept the Moon's gravitational field. Then Orion will perform a series of 2 engine burns to completely settle in NRHO. But why NASA has chosen NRHO out of many potential orbits? It is because it's gravitationally balanced location between Earth and the Moon, so the spacecraft fuel efficiency will be optimized. Due to this important factor, a lunar space station called Gateway will be built in the orbit by NASA and its partners. This place will be the cornerstone of Artemis' long-term goals and will be a place to access the sites all over the Moon, continuous communication with Earth, and a resort for astronauts and future Moon tourists. More on Gateway later in this video. A SpaceX human landing starship has been selected by NASA to transport crew on Artemis III mission from lunar orbit to the Moon surface and back to the lunar orbit again. Before the crew mission, a SpaceX human landing system will travel to the lunar surface in order to go through several critical tests by NASA to assure its safety and readiness for human lunar landing. In order to increase overall efficiency of lander, a SpaceX will be using a special concept of operations. Before the Artemis III launch, a SpaceX will be sending a storage depot to Earth orbit. A storage depot will be used as a place to fuel a SpaceX human landing starship. The fuel is provided by the series of reusable tankers that carry propellant to the depot. Afterwards, the uncrewed Starship human landing system will be meeting at the place a storage depot is located in order to be fueled. Then, a translunar injection engine burn will steer the Starship to NRHO, and the journey is going to take approximately 6 days. The SpaceX human landing starship will reside in the orbit waiting for the Artemis III crew's arrival. When both spacecrafts meet, the Orion will approach the starship for docking. When both spacecrafts attach together, 2 of the crew members in Orion and their supplies will be transferred into the human landing starship and 2 other crew members will remain in Orion capsule. Orion then will undock and withdraw from a starship and stays in NRHO for about 6.5 days. This is one complete orbit around the moon, so when Orion orbits the moon one full time, the crew on the moon's surface will finish their duty in there, board the SpaceX Starship, and will be launched to lunar orbit to meet the fellow astronauts at Orion spacecraft. The moon's south pole has been chosen by NASA for landing. The South Pole environment is very harsh for astronauts, but it will be a good place for expedition because of its unique conditions. Scientists believe that below the moon's surface is abundant with water, especially in its South Pole craters, due to the lack of sunlight in that place. The craters might even contain the vast amount of hydrogen reserve and water ice underneath of only 1 meter of lunar regolith. High-resolution maps provided by NASA's Lunar Reconnaissance Orbiter attest that there are large areas of water on the moon. However, NASA is not certain about purity of the water and the exact location of it. Moreover, there is discussion about the possibility of turning the water into fuel for spaceships. This area of the moon surface hasn't been explored, and there are lots of mysteries about the region. By exploring the lunar South Pole, many discoveries can occur to help scientists have better understanding of deep space. After the Starship touchdown, the systems will be checked by the surface crew to ensure readiness of them to stay on lunar surface for 6.5 days. Before starting the first full day of lunar expedition, the astronauts need to eat and rest in order to recharge themselves. During the Artemis II mission on the moon's surface, astronauts will conduct duties and tasks inside of the Starship and also performing moonwalks to explore the surface. To carry out the moonwalk, astronauts will exit the Starship through an airlock and then descend on a Starship's elevator. Astronauts will wear a state-of-the-art and advanced spacesuits designed and manufactured by a company called Axiom Space. Axiom Space has been selected by NASA due to the fact that the company can design and manufacture the spacesuits more quickly, efficiently, and less costly compared to the ones manufactured by NASA. Axiom will also supply spacewalk systems for Artemis III and future Artemis missions. The spacesuits will give the ability to astronauts to explore more of the moon's landscape due to their higher range of motion and flexibility. Moreover, the spacesuits are equipped with multiple headlamps to explore the dark south pole of the moon more conveniently. According to Axiom Space, the spacesuits can fit almost every type of body shape. In other words, they are custom-made to fit people with different body sizes. During the moonwalks, astronauts will take pictures and videos, collect samples, and retrieve other data to fulfill and attain the scientific objectives. The region is very dark and astronauts explore the area with navigational tools and also their spacesuits' headlamps. During the expedition, astronauts will relay information to mission control teams on the Earth about what they see, hear, and feel. By sharing the information, an unprecedented human experience can be contributed to the world to increase our understanding of the mysterious South Pole region, the Moon, and the solar system. When the mission on the Moon's surface is done, 2 astronauts are ready to join their crewmates in Orion. A SpaceX Starship will fire up and launch towards the Orion spacecraft in lunar orbit. After docking, transferring of samples between the spacecrafts, and preparing for the journey back to the Earth will take place by staying 5 days in lunar orbit. Undocking and firing the Orion spacecraft engine must be done when they reach optimal NRHO departure point, slinging the spacecraft past the Moon in order to comfortably dispatching it toward the Earth. During re-entry into the Earth's atmosphere, Orion spacecraft will travel at the speed of about 40,000 kilometers. A spacecraft will splash down in the Pacific Ocean with the help of 11 parachutes, and the crew will be retrieved with support from the US Coast Guard and US Navy. Artemis IV mission is planned for September 2028 and will be a continuation of building up more space present for humanity. NASA stated that this mission will also include a human landing on the surface of the Moon. However, there will going to be another duty for this mission, and that is building up the first element of the Gateway lunar space station. The first component of Gateway that will be installed is a habitation module called IHAB. This part of the lunar space station, as the name suggests, is the place for astronauts to live and dwell. The duration of the Artemis IV mission really depends on how long it will take for astronauts to assemble the IHAB. Japan is going to play an important role in constructing the Gateway. In addition to building up the station, as mentioned before, astronauts will still need to land on the lunar surface, and for this purpose, SpaceX Starship Lander Option B will be used. In later Artemis missions, more elements and components will be built and adjoined to the habitation module. The Gateway Lunar Space Station, after completion, will operate as a place for astronauts to live, work, and research. During their stay, the space crew conduct scientific research about heliophysics, which is the study of Sun, its planets, and a space environment as a dynamic system. Moreover, human health, life sciences, and other scientific domains will be studied and explored. The Gateway will be the foundation in developing technologies and capabilities in order to make exploring Moon and Mars a possibility in the near future. Artemis Moon missions indisputably will shape humanity's future. Successful Artemis I mission was the opening to a new era in human history. Hopefully, the second Artemis mission will be happening as soon as April 2026. And after that, Moon will be within our reach. Artemis will improve our knowledge about the Moon and beyond, with developing novel technologies that make us capable of going further into space exploration. NASA mentioned that Artemis missions are not only about the Moon, but rather about the future of humanity expansion into other planets in our galaxy. The Moon is just the beginning.